All right, what's going on, server side express brothers and sisters? We're here picking up with another video in this playlist to add to it. I indeed got a follow-up question in our Discord from a student, actually alumni at this point now, wondering, hey, Cool Hand Luke, do you think you could do a part three to the server boilerplate for a service controller layer? I found myself in a situation where one round has to do a lot of work. We're going to get to this, and it'd be super nice to just pop all that in another file and replace it with a do work function. So yeah, this is a great question to ask that will have some solid video content here. So let's go ahead and dive on in. Hopefully you don't have to watch the previous two videos to get this. I think I've pushed this to a GitHub repository. If not, I will here. I did. Okay, so yeah, I do have a GitHub repository. So if you aren't caught up with this video, you can always go check the description in the video below to clone and find the commit for this part here. That way you can go ahead and get it as well. Obviously, you won't have the same database schema as I do for this example video, but you can always go back and watch those and recreate it. But ultimately, rather than having to actually code along, this is going to be a better idea just to watch conceptually, because that's what we're going to be talking more about. So the student, or rather alumni, we're all students, let's be real, like I'm not up here claiming I'm infallible or I don't make mistakes. I like to be corrected and I take constructive criticism well, and in a professional way at the very least. And, like that's fine. Like, so some of the things I might show you pattern wise may not be what I do at like an enterprise level, but when I'm making like these projects for my students and fresh alumni to learn from, I'm always trying to just kind of expand their knowledge base and help them figure these things out, put some terms on that they can figure out, and write these as like one-man army style projects, because I'm not going to have 60 people all working here at once. But this is really good. That question that student asked is really good. Alumni, whatever, right? Like I said, we're all students on this journey together of learning, and that's the important part. We're supposed to help uplift each other and not put each other down. So yeah, this student probably, without even looking at their code base, has probably a lot of business logic occurring in an individual route. Now, in this little function right here, it's meant to get a list of user emails for like a fake little cult I made that I have for practicing aggregate functions with my students in the database section of our full stack development bootcamp. Where we have just like, I think it was like 500 plus emails that we get from here for some cool aggregate data we can do. But let's say we had an example route. So this is going to get angry at me because I won't have anything. I don't have like the functions ready for this. So we're going to have to think of pseudocode here as an example of where this student is finding themselves in trouble. So let's say they have a route that looks like this. They want a route that will register new users to this particular project. So they're going to include a rec res next in this function right here, and then from there run a try catch. Nope, not truncate sync. I don't know how I managed to do that. Well, they'll daisy chain this to their global error handler that we covered in the previous videos. And here they might have something akin to the following, right? So maybe they'll have something like, they're going to maybe validate their is valid. Then maybe they have some kind of, I'll have to do this as pseudocode, so apologies on this, but it is what it is. Otherwise, I'm going to have errors and stuff everywhere. Maybe they have like a validator of some kind saying, well, I'm going to be doing something with the request body. I got to make sure it has the correct properties on there. I got to make sure it's a valid email. I got to make sure it's a valid password that I've checked on the front end and stuff like that. So maybe you have like a validators function or object that has a function for validating a user's info. You pass in the request body. This is also a bad idea right here. And I've talked about this in my other server videos. So keep that in mind, that I've talked about why you shouldn't do this, but I'll rehash it here in just a moment with the pun intended of hash, considering we're about to register a new user. So we'll say if the user is not valid, we want it to return I can't even type today. My fingers are off home base. Let me shift my keyboard. There we go. A bad status code. That's not any better, evidently, Luke. Come on, man. 401 or 400 bad requests, because this is just the request body being incorrect here. So we can send a set of status code and maybe some kind of JSON response if we wanted to, since I've been trying to be consistent about that. Just to say like, bad request body or something like that. But again, that's what your status code is already telling you anyway, but I like sending myself string messages. So like this would say, hey, if that user's information isn't valid, let's go ahead and make sure that they don't continue the process here. And then if they get this far, then we're going to say, all right, let's make a new user where we'll have like our database. So we do have await we'll say the join us from the previous video's examples, .users.insert, where we're going to insert that information into the database right there. Then we get that information, right? And from there, we need to also, before we do that, like we needed, what's it called? We needed to make like a salt where we'd have like await, bcrypt dot gen salt 12 rounds, and then we'd have to do the following: const hash equals await bcrypt dot gen hash, where we take our rec.body.password that they're trying to register with, where's our salt. Then after that, we need to take the rec.body.password and replace it with our hash before we insert it into our database. There we go. Now that we have the user record, we want to make sure that that information is not carried anywhere, because that would be very, very, very bad. So we'd have to have this logic here to make sure we delete their password off that user before we do anything with it. And then from there, maybe there are some other tables. Like I imagine if the student says they have a lot of work being done in a singular route, that they probably have something akin to this, maybe, where they have to create a table and insert something else. Or so maybe it'll be like const game record. I'm not sure if this is what they're going for, but this particular student in our course built a idle RuneScape playing game as their final project. I thought it was amazing. So maybe they have like a records table that they're inserting some information to. So maybe from here we'll say await join us.games.insert new user information, that we would have to insert that user info to make a record of that. Maybe they're going to send some kind of email or something like that might say await. Again, this is just all pseudocode here, but I'm just trying to point out that this might be some of the work they have going on before I begin separating controllers and services, defining them, and showing us what we can do here. And trying to, again, like have a crowbar bit of separation. Maybe they have like an email service class or something like that will then send an email wrapped around that user's information or something like that, right? So again, I could sit here and write out like 50 more lines of pseudocode, but I think y'all are beginning to get the point. We'll say message success on registering a new user at the end of the day. That's what all this thing needs to do. So again, a bunch more pseudocode's gonna keep on driving the point home, but I think y'all get where I'm going at. This is not a whole lot, but like I said, that student probably has a lot more than this going on if I'm thinking about what their project is working on. But either way, this is a lot of business logic happening inside of this route, aka a controller, as far as Express is concerned. And we're beginning to mix and match things that I've talked about, like sending anything from your request body into your data layer is a bad idea. Having any kind of SQL directly inside of a route's endpoint, its action, is also a terrible idea. We've already accommodated that problem by, as you can see, making this database layer separate from our routes. And that is one of those separations, those degrees, like that, those separations of concern that I've talked about here. And that is already being accounted for in this example. Now, the other big thing I told y'all not to do is to do anything with the request body directly, because when it comes to future, like when you're adding tests to your Express applications and you're doing testing, making very complicated mockups of the request body is a nightmare and a very annoying thing to deal with. So this is where I would always recommend having what's called that data transfer object. Well, I will say, give me a copy of the rec.body, but don't modify it directly. And this is like one of the first things I will tell you is, don't pass the request or response object to a service layer. It's got to stay here in the controller layer, right? And so just doing this right here and replacing the rec.body in places with the user DTO is a much, much better idea, right? So anywhere I see rec.body, I can change it now to something like that, where I have my user data transfer object that represents those values instead. So, and we'll say the same thing here for... Again, I know. Right. So at this point, we've already have one of our kind of rules we're going to be following is we don't want to take anything from our networking layer, our controller layer, aka HTTP request and response headers, statuses, status codes, or anything like that. We don't want to be taking them into our service layers. We'd also want to make sure our services don't return any of that information, right? So we want to make sure that This is where our status codes and our responses and things like that are being set and sent, and not from moving this to a individual function that we're calling that returns what our response should be, for example. None of that should be done. We want to keep our HTTP information in the HTTP layer, aka right here in the route itself, and not anywhere else. So what I would say to keep in mind is the following. We want to kind of think of controllers as our managers in this analogy, and our service functions or service layer as workers. Okay, so typically the point of a manager, again, like you might be rolling your eyes because all of us have had bad managers out there. Maybe we are the bad manager. I don't know. I managed a coffee shop for 10 years before I began learning how to code here at Covalence. I kind of roll my eyes at this analogy, but it is what it is. But we're going to think in an ideal world, our manager would typically, they would manage the incoming work requests. They're going to decide which worker is going to be handling and doing the work. They're going to split it up into sizable, doable units. There's an eye roll. That's what they're supposed to do anyway. They're gonna see the incoming work, go, this person can handle it. I'm going to also break it into smaller bite-sized pieces that they can handle one at a time rather than an overwhelming task all at once. I'm going to pass that work off for the worker to do. And if I feel like this job requires multiple people, I'll split that work amongst multiple people. But I ultimately, if I'm being a good manager and a good worker, don't do the work myself, right? I will simply pick who needs to be doing this work, the allotted time, and breaking it down to smaller, doable steps for my worker. That's the point of a manager who is the controller in our example here. So this is where we would see what incoming work needs to be done and splitting it up as needed. Our service is going to be the actual worker, right? I'm going to receive the request from my manager, aka the controller. I will figure out the individual details involved to do this request, and I'm generally only concerned with completing that request and nothing else. I don't have an idea of what the bigger picture is. I'm going to focus on the small task given to me and execute that and do that to the best of my ability. I'm going to let my manager deal with the big picture and all the other incoming work. And I will only do the work necessary to the request. I'm not going to run any side effects or run additional jobs or things like that or try and jump and help someone else. I'm going to just do what's assigned to me, and that's it. And then when it's done, I will return it to my manager and call it a day. And this is what we're going to define as our service layer, the actual worker. So small scope, has a task presented in front of it, does that task only, and doesn't care about anything else. The manager will handle the rest, which is our controller layer, right? So basically, the controller is going to handle the incoming work HTTP requests. This is our controller layer. Right? This manager is deciding which function or which function service eventually should be running, right? Now, an example like this is really very, very simple, but I'm not gonna break that one apart. That's what's going on here, right? We want to make sure that it's breaking apart like that way. It's going to split it up into small, sizable chunks. It's going to decide who does the work, and yeah, that's what our controller is going to be. And the same thing for our service. This is where we're going to have any kind of business logic, algorithms, database calls, maybe third-party API calls, like all that kind of crazy stuff is going to be done in our service layer, right? So the controller will manage and orchestrate the work, and then the service will actually execute the work. So what would that look like in an example like this? This isn't extraordinarily complicated, but it is what it is. So first and foremost, how do I split this apart into a controller? Because again, that kind of goes back to the heart of the student's question. Well, let's take a look at an example of how I would do this. We're going to pretend this is some other file. Like, I don't know, could be something like up one. I'll probably leave it in routes and controllers. Yeah, so we'll say maybe it's up one into the routes file. We have controllers that will be following the same idea as our, as our routes right here, So maybe I have a controllers folder that this routes actually, it would make more sense that the routes folder becomes controllers and we break it apart into services from there. So this might change the name to routes instead, but it is what it is. We'll for now, we'll say we'll have some mythical other folder called controllers that mocks exactly what our routes are going to be here. So controllers, the join us project, and the user's endpoint files here. And our controller might look something just like this. It's going to be end of the day, a function. called maybe register user. Okay. And maybe we're going to write a named export on this thing. So export const register user. It is going to be an asynchronous arrow function that runs the following, and it's going to receive those values, for example, from our code base here. So, right? Yeah, because it's going to have to know the rec-res next part. Yeah. So in terms of TypeScript, this is where I would have to use some types from Express here. So I'll import them down here. Again, this is like an example. So import the types of request from Express, response, and the next function. I just want their types here. So that's what rec is. That's what res is. And that is what our next function is. So, basically we're setting up our little handy dandy function here, and it's going to be running this and all that pseudocode that I showed y'all. So paste that in there, and as you can see, it just kind of handles what the code is supposed to do anyway with all that lovely pseudocode inside, which this one I can probably actually move out here so it actually does something if I want to test it. But there you go. So we've essentially moved out the code that was in the post function directly, and we've already begun breaking out into now 2 layers. Here is our networking, aka our controller layer. So instead of having a function directly written on this endpoint, what I'll instead do is I'd import this register user code here as something called controllers dot. So honestly, I should do the following for my example. Like this is where I would export this. Maybe call it users controller, and assign it, make it an object, and give it this property so I can show y'all how I would do it. There we go. So right, I would import this into this file, and in place of this right here, I would say, hey, on the user controller import, fire off the register user function. And we can do the same thing for this little dudette right here, where I can say, hey, maybe we're going to call this const, I called it register user, get all users will be that async function that runs the following code. Let me go and correct the TypeScript args here as well. Boom. Okay, now that I have that set up, let's go ahead and add that to my list of exports here. So I have my controller set up. And before you know it, up here, we're going to have just a list of routes that might have parameters, some matching, some query params, things like that. But ultimately, this controller or route file ends up looking like this, where it might be a ton of these with different names and different functions running on different routes. This is where our manager is looking at this and going, oh, it's an incoming request to this worker will handle it. Incoming request to this with these params, this worker will handle it, and so on and so forth. And this is also a much more scalable structure when you begin adding things like validators. So I would even say that this pseudocode right here of validating our request body should be handled via another middleware we may write, for example, or via a validating library that I like to use, either Joy or Celebrate. They're both really good libraries to look into. Maybe I can do that in the next video of this series if there's more interest in that as well. Get in the comments below. Let me know in a professional way that you'd like to see that. Or if you're part of our Discord community as your student or alumni watching this, just ping me or DM me and I'll be happy to acquiesce your request. So yeah, I mean, this is like a common breakup you'll see here. And again, like if we had validators, this is where it would go. It'd be like validators for, actually no, I mean, I wouldn't really care for a validator on getting all the users. But for example, registering a new user, I would have validators, or if I was using Joy or Celebrate, this is where I'd use it. User body, something like that. So that way we have a similar middleware that will run this little pseudocode here first and end up doing some work for us, right? So there we go. That's how you start breaking apart and adding more middlewares, because maybe they also have to be logged in to get this. Maybe they have to be logged in with token or something like that. And as you can see, like the more middlewares we begin daisy chaining together that begin separating these things out into more and more layers, the individual endpoints themselves are going to get very messy if you're not very careful. So that's why I do recommend breaking it apart into smaller bite-sized chunks wherever possible, which is what that individual's question is, and hopefully I'm answering as we go along the way here. So again, like this wouldn't be written in the same file as our route. This would be in another file. So now that we're thinking along the lines of controllers and how they are managers that will deal with the incoming HTTP requests and sending the responses and stuff like that. How do we take this logic and break it down even further? Because once again, this is a lot of business logic happening inside of, again, a controller. So we want to keep some separation of concern with business logic here. All this stuff doesn't have to happen inside of an individual route. It needs to happen in a service file. So maybe I have a new folder called join us in services, and I have a users.ts. Now, this is assuming that you're going to have like a mega server here that is going to be linking up multiple projects on one DB, which I think might have been my intention when showing y'all here. But if this is a single project, then you can just have services, and I typically have them named based on what their point is or what table they're associated with, right? Or tables. So, when we have like a users inside of the join us project service file here, where once again, I could take my logic and still break it apart even further to try and make this a bit cleaner looking. So here is where I would have, again, like maybe we don't have a validation library. So maybe this is where I'd have like a const validate user body file here that when passed a user body, it will then run that pseudo logic for me and do some code for me. So this is where I would ask it to go ahead and validate that information for me so we can break it apart. Now again, this is all pseudocode, blah blah blah. And it will, rather than returning any kind of HTTP data here, right? And we don't have to have the user DTO at this point because it should have been passed in as the user body, which means that's what we're going to do there. If it's not valid, we're going to return false, and otherwise we're going to return true that it's valid so we can continue on to the next step, right? So that's where I would then, it would be basically taking this kind of logic right here and importing and using that file instead. So it'd be like user validator or something like that, right? Looking at my notes here to make sure I'm not falling off course. Yeah, I mean, it'd be something like that. It would just be the same idea. It'd be validate user body. So we can even do, if you wanted to, you could even do the following. User body, where I would pass in that. Why did I delete it from here? That's interesting. I'm a dummy for deleting it from here, but I think I was trying to show something earlier. But yeah, there we go. Pass in that user DTO into that sucker, let it tell if it's valid or not. And this is where the status request would be handled. And the more complicated your logic is here, this is where I would write like my regular expressions if it's valid or not. So I would take like, I would look through the object, and then here's where I write the code to, run some loop over the object, checking for correct keys and values, check email with regex, check password with regex, something like that. So here's where I'd run all that logic here on the user's body to validate it, send back a Boolean value, and then let this actually handle the status request, because now we have a service for validating the user body that is now separated away from the controller itself. Same thing for this information here. I'd probably include this somewhere in a separate file. Const add user will take a user's information and add it to our database, like that. So obviously I'd have all this as pseudocode and such, so on and so forth. This wouldn't need to really worry about sending any information anywhere, right? I mean, like back to the service layer, maybe want to return our user record when it's done because we have to do something with it, which I believe we do in this example we're using here. I'll call this the new user as the arg, and that way it's what? New user.password, new user.password, new user. Okay, cool. So, and then we return that user record from this function here, right? So that way our controller gets even more simplified when it ends up just becoming const user equals, and maybe we have like a user service file we were importing this from. Again, like this would assume that we are doing the same trick down here of exporting an object out to reference. We can say user service validate user body, user service dot, I think I called it add user, right? Add user. So we'd say add user and then pass in the user DTO after we made sure it's validated or not. So that's taken care of right there. Same thing for, like, let's say a game record. We would have a games.ts or something like that. This is all just examples here. Games.ts, where we would have const, what is the pseudocode I've made up so far? Insert like a new game record. Const new user game record, where we take in a user record and fire off some pseudocode there. Again, it doesn't, all I'm doing here is pseudocode. So hopefully this is clear to that individual that asked that question. But this is how you'd break it apart here. So from there, we would have, instead of this, we would have not even a database insert. We would have this database insert basically happening from here as our pseudocode. There we go. There we go. Return that game record after that's done. And from here, back to the route. Yeesh. I would have what? Yeah. User service dot, actually be game service in this example. Oh my god, the pseudocode is killing me. I should have just made real code. Game service dot new user game record. These are terrible names, but again, the point here is that we would have multiple service files helping us break apart the business logic and separate that concern to say, hey, I have a service for sending an email based on some user info to do some kind of logic. Right? So you would do all this information here to ultimately, as you can see, take all that complex code we otherwise had and distill it down to a couple of service functions that return values to us that have nothing to do with the HTTP layer. I never take anything from the HTTP layer and pass it in directly anywhere, in the same way, the reverse, that the worker doesn't send back what the response headers, what the response text, what the response status code should be. That's all set from this layer here. And we've created multiple service file examples so we could see that otherwise long and kind of complex logic became a couple service calls because they're going to focus on their individual tasks to get done. After the service calls are done, we set a response, and then we import the object that has these controllers on it, and when we add them to the routes here. So this is where our manager is looking at the incoming HTTP requests and assigns our workers to get the job done. Our manager comes down here and says, hey, I have these incoming request information. I'm going to make sure that I give the relevant information, a copy of it, to my service workers to get their individual task done. The service worker gets a task done, and whether he tells us whether it's valid or not, but doesn't set the response or the status or send one, for example. We have that logic written here. Same thing down yonder. If this threw an error, it would be caught and handled by our controller and not from the service itself. This service took all that logic of making a hashed and salted password and returns that value user record to us here. Then maybe something else happens by adding a new games record by using a game service. Then we have some kind of emailing service. We want to make sure that once a new user is registered and they have a record ready to go, we say, hey, here's this user's information, send them a formatted email that looks nice. That says, hey dog, good job on your, thanks for registering. Here's what your game record's going to look like, and go ahead and get going. And this nice little message at the end tells our website that the user has been successfully registered by all of our individual workers, aka the services, and all of that project has been managed by a controller, aka our manager, where we delegates what work needs to get done and by who. So I know a lot of the pseudocode, even I was confusing myself in the long run here throughout this video, but hopefully this degree of separation, this TLDR of where things go, right, is a bit clear of how I would break things apart. This is a good way of writing a more scalable server structure in the long run, because once you get validators and several middlewares acting, especially when it comes to auth and things like that, if you have tons of middlewares being added onto your individual endpoints, that codes get super long and nasty. So having that extra space here for all your middlewares and all your cool routing tricks very isolated up here in the route itself, and the endpoints are super cool. Having the ability to move those endpoint code functions away is where I would start to answer that student of how they should start cleaning up their code. If you find your function getting super long, just build out a controllers directory. I would call this your networking routes. The controllers directory would be the actual endpoint code that runs. And then if you find your endpoints also getting super duper long code wise, then take that additional step to break them into service layers like this that help break apart what the code is trying to do. That way your code gets more and more layered, right? So if I was helping you figure out a routing problem, I could hang out in your routes and controllers while you could figure out the actual logic by messing around in the service file, and we're not bumping into each other on a collaborative project using a source control like Git and GitHub, for example. So yeah, that's the general idea. This would be in its own directory as well and not in the same file as the route endpoints themselves. This would be like routes, this would be controllers, and you'd export it out as controllers. So yeah, this is a lot more conceptual, like I said, than actual code writing here. So hopefully that answered the student's question. Anyone else out there that is a newbie Express and server-side developer has a better idea of where the service controller and database layers come from in larger scale structures. Like, again, if you were like me when I was a fresh alumni of Covalence, I came across a sizable server-side project and I felt totally lost because I knew of these terms, but I hadn't seen them in action or use before. So the student's question was, how do I break it apart into just a do work function? This right here is what you're looking for. Ultimately, register user is just a function that does the rec res next handling just like it did before, except now it's just its own individual function that we choose how we want to export, and then we simply import it and add it to our route, right? Because that student also had a do work function example like that. That is not what you want to do, because that would presume that you are, again, remember in JavaScript, functions are first class objects. This will get executed to its completion, and whatever it returns will be placed on the route and be ready for action. So this is not what you want to do. What you want to do is simply say, hey, here is a function to be ran when this route is hit and not before, right? So remember, that's the key difference right there. But yeah, I know I went kind of rambly there for controllers and services, and I got there eventually, but hopefully this clarified that information and you can see where the shorthand and scaling structure will come from. So yeah, if you have more questions, feel free to hit us up in the comments in the video below. Make sure to like and subscribe as well. And yeah, otherwise, if you're already in our Discord community, then just ping me there if you want any clarification or additional content for this series. Thanks.